Research that may help save the planet is being conducted in the most unlikely place, a motorway rest area in the northeastern American state of New Jersey. What is being tested here could have an enormous impact worldwide.
My name is Balaguru. I helped to develop this inorganic paint called Ultimate Paint.
These patches of paint are helping demonstrate some remarkable qualities. Ultimate Paint is graffiti resistant. It can repair concrete. It's impervious to mold, is fireproof, and dries to nearly the hardness of a diamond. Paint your home with it once, and you won't need another coat for about 1,000 years, says Dr. Balaguru.
Chemistry of this coating is an aluminosilicate. This is the same formulation they use for the Chinese terracotta army, which is more than 2,000 years old.
But what really makes Ultimate Paint special is its ability to clean the air we breathe.
These properties comes from an ingredient called titanium oxide. When the sunlight hits the coating, the UV energy essentially destroys the organic particles. The titanium oxide, the other ingredient, acts as a catalyst and uses the sun's energy.
Applied to exterior walls, Ultimate Paint could help clean the air of polluted cities around the world. Nitrogen oxide, which is found in car exhaust, reacts with surfaces treated with Ultimate Paint. Nanoparticles in Ultimate Paint, activated by sunlight, break down the toxic nitrogen oxide into harmless nitrogen and oxygen gases.
And essentially, we can use the entire transportation infrastructure as a cleaning surface.
Ultimate Paint is still being tested, but initial results, including those from along the motorway, are promising. But even Ultimate Paint cannot address one of the biggest inefficiencies in modern buildings: windows. Scientists Ed Tracy and Satyen K. Deb think they have a solution.
Are you looking for a window for your home? Do you want the best window in the United States? Well, I've got the product just for you.
They have developed a new technology called an electrochromatic window. With the press of a button, you can control the amounts of light and heat that pass through glass.
I'll use a 1.5 volt battery, change its transmittance characteristics. I can now bleach the device by reversing the polarity.
This commercial-sized window uses 5 layers of thin ceramic film, each less than 1/50th of the thickness of a human hair. When a low-voltage current is applied, the window slowly darkens. Reversing the polarity of the electrical current causes the window to become clear again.
In some ways, the building starts to become alive. It responds to the natural environment. At critical times of the day, the building can start to throttle back, to shut down a little bit, only to open back up at the right times. This is sort of moving towards an idea of a living building.
It's estimated that if this window technology were deployed across the United States, the energy savings would be 2 to 3%. That may not sound like much, but it's the equivalent of 2.7 million barrels of oil per day. Electrochromatic windows are still very expensive and represent only one part of the energy-saving equation. The next generation of smart building design is being put into practice in Pittsburgh, Pennsylvania, at Carnegie Mellon University's Intelligent Workplace.
The Intelligent Workplace is considered a lived-in as well as a living laboratory. We live here, we do our work here, but we're also constantly experimenting with things and also trying to demonstrate products that can be used now.
Some very intelligent people here are working on some very advanced technology for your home.
I'm basically going to be doing exhaust gas analysis.
I'm working on developing controls for the fan coils using sensor networks.
I'm working on the biodiesel-fueled engine generator with heat recovery, which is part of the overall Intelligent Workplace energy supply system.
Known to most of us as air conditioning. Attached to the exterior frame of the space are smart louvers, or blinds.
What the smart louvers do is they have a sensor on the roof that tracks the location of the sun, using computer algorithms, controls the louvers so the angle of the louver matches the angle of the sun, blocking out the glare. They can reflect light into the space so you don't have to use as much artificial lighting, and it also filters out some of the UV